Okay, so we talked about horizontal and vertical asymptotes yesterday. Today we're going to talk about slant asymptotes. Pause the video and copy this down. Okay, if the numerator is exactly one more than the denominator, so like right here, it's 3 and 2, that's one more than this, then we'll have a slant asymptote. Remember, this is a button, bigger on the top, so there's no horizontal asymptote, and I always kind of remember it that there's a slant in the end. That's the slant asymptote. They also call these oblique asymptotes, and you should know both names. And it says what we need to do is we need to do long division, which you learned in Algebra 2, and I'm going to remind you how to do it. And the quotient is all that matters. The remainder is not important. So these, we don't have to actually be as careful as we did because we don't care about the remainder. We only care about the quotient. So I'm going to line this up above where it goes. So what times x squared will get me x cubed? Well, an x, so I need to line the x up above the x here. And then I'm going to multiply times this. X times x squared is x cubed. X times negative 5 is negative 5x squared. X times 6 is 6x. Then I have to subtract all of these, because when we do long division we have to subtract. So I'm going to subtract everything here. Subtract, subtract, which is going to make this a positive, and subtract this one. 3 minus 6 is negative 3x. Negative 3 plus 5 is 2x squared, and these cancel, which is what I wanted. Now, what times x squared gets me 2x squared? Well, 2. Now, at this point I'm basically done, but I'm going to go ahead and do this next step. I'm going to bring this down. 2 times x squared is 2x squared. 2 times 5 is negative 10. 2 times 6 is 12. And I would subtract this again. Now, I don't care about the remainder, so it doesn't matter if I go any farther. As soon as I have my constant term, I'm done here. This is my slant asymptote. Y equals x plus 2. All right, so let's do that one more time. So to write this out, I put the top part goes inside the divide house. And don't forget, this is just like when we did synthetic division. I have to put in the missing term there. Notice there's a missing term. And then I say, what times x gets me negative 3x squared? Well, negative 3x. Negative 3x multiply. Negative 3x times x is negative 3x squared. Negative 3x times negative 1 is positive 3x. I'm going to subtract everything. So I change the signs on all of this. 0 and negative 3 is negative 3x. Bring this down. This cancels. What times x gets me negative 3x? Negative 3. And I can stop right there because I don't care about the remainder. This is my slant asymptote. Y equals negative 3x minus 3. All right. Pause the video and copy this down. All right, these are just our steps we went through. First of all, factor. Find any holes. Those are the ones that cancel. Find the x-intercept by letting the numerator equal 0 and solve. Here we're letting y equal 0. Then decide whether there are bounces or pass-throughs from multiplicity. The y-intercept, we're going to let x equal 0 and solve. Find our vertical asymptotes by setting the denominator equal to 0. Find the horizontal or slant asymptotes with our Bobo Botan. Eats dark chocolate. And then sketch out the branches of our curve. So here, this is a hole, our x and y intercepts, our vertical asymptotes, and our horizontal asymptotes. Okay, this is page 7. I'm going to do the last two examples really quick with you. I've already factored them. These cancel. This is my hole at x equals 2. And I plug this back in to what I'm left with, which is 2 x plus 2 over x plus 3. I plug this in here, the x in here, to find out my other part of my whole. So 2 plus 2 is 4, times 2 is 8, and on bottom 2 plus 3 is 5. So I've got 8 over 5, which is 1.6. I can divide that out. Then my x-intercepts, I'm going to plug in on the top, I'm going to plug in y equals 0, which is just affects the numerator. So I have 0 equals 2 times 2 plus x plus 2. Well, I can divide by the 2, and then I see that x is negative 2. So this gives us the point negative 2 and 0. Then for my y-intercept, I'm going to plug in x equals 0. So 0 here, this is 0, this is 0. This leaves me with negative 8 over negative 6. Because 0, 0, 0, negative 8, negative 6. So this gives me 4/3. 0 and 4/3. My vertical asymptote is this one at x equals negative 3. And my horizontal asymptote, well, these, the exponents are the same, so the exponents are the same, so divide coefficients. When I divide the coefficients, I have a 2 on top and a 1 on bottom, so I get y equals 2 over 1 is 2. I'm going to go ahead and draw mine in with a highlighter. So my horizontal asymptote is at 2, that's right here. My vertical asymptote is at negative 3. 1, 2, 3. I know that I have a hole at 2 and 1.6. 1, 2, 1.6 is right here. I know that I have an x-intercept at negative 2. 1, 2 right here. I have a y-intercept at 0 and 4/3, so that's a little over there, so that's right there. So I know this part of the graph for sure looks like this. Then I just need to decide if this part of the graph is at the bottom or the top. So I'm going to plug in like 1, 2, 3, 4, 5, like 5, negative 5, and see what we get here. 2, negative 5 would be 25. Minus 8 is 42 on top. I'm going to plug it in on bottom. 5 squared is 25. And I'm plugging in negative 5, so that's minus 5. And then minus 6. That would give me 42, and that would give me 14, which is a positive number, which tells me that this branch here, I could finish dividing that to find out what it is, but it's like 3 point something. So I know at 5 it's at 3 and a little bit. And that tells me that this part of the graph is up here. All right, one more, last one real quick. These cancel. That gives me my whole is at 2. And I could plug in the 2 here. And in my reduce 1 to find out that I've got 5 over 5 is 1. X-intercepts. Well, it cancels out, so there's nothing on top for where y equals 0, so there's none. My y-intercept, that's where x equals 0. So I'm going to put in a 0, 0, 0, so I get negative 10 over negative 6, which gives me 5 over 3. My vertical asymptote is this one, so that's at x equals negative 3. And my horizontal asymptote, this is bigger on bottom, 0, so that's at y equals 0. So let's draw those in real quick. Y equals 0 is here. X equals negative 3 is 1, 2, negative 3 right here. I know I have a hole at 2 and 1 right there. I know my x-intercept is at 5/3, so that's 1 and 2/3, so that's like right here. So this part is going like this. And then this part, I can plug in a negative 1, 2, 3, 4, negative 4 in here and see what we get. So that's negative 20 minus 10 is negative 30 on top. 4 is 16 plus negative 4 minus 6 is 6 on bottom, which gives me -5. So at 1, 2, 3, 4, it's at 1, 2, 3, 4, 5. So this one is definitely going down like that.